So the Flextura cluster system is a piece of equipment that allows you to deposit thin films, anneal them, and characterize them without exposing any of these samples to an atmosphere or even without breaking vacuum. So it consists of 5 chambers. So the first chamber is the load lock. You can put in 10 samples here, and which allows you to really go and do a high throughput of samples, can investigate a large parameter space. So the 2 deposition chambers first one is a more standard magnetron sputtering chamber. It has 5 sources. You have 2 RF, 2 DC, and 1 high pins source. You can do temperatures up to 1000 degrees, and you can have atmospheres of oxygen, nitrogen, and hydrogen as well. The second chamber is a bit more of a special chamber. So it's specifically designed for the University of Oslo. It's quite unique. It has a remote plasma generator, meaning the plasma is generated externally into this chamber, externally with an RF source, injected into the chamber and held in place by electromagnets. So what this does is that it decouples the plasma density, which allows you to do quite reactive or high reactivity of the deposition. But you don't necessarily have to do such a high power on the target. And because we have these retractable targets as well, we can place the target inside in the very thick of this plasma, where it's a very high plasma density and you get a high growth rate. Or we can also deposit a little bit more outside, where you have a much lower growth rate. That means that you can have these very reactive species and you can combine it with a low deposition rate. What that means is that when you have adatoms that have come to your sample substrate, they have the time to move around, they have enough energy to move around and find the least energetically favorable position. And this allows us to do epitaxial growth. Thirdly, we have an annealing chamber. So this annealing chamber, after you've deposited, you can send it in the sample into the annealing chamber, and you can heat treat your samples up to 1000 degrees and in partial pressures of oxygen or nitrogen, which you can control. Additionally, what's a specific feature of this annealing chamber is that you can do a so-called metal atmosphere. What that means is that you have a sputtering source on the side that sputters somewhere else, and the thermalized metal ions are drifting across your sample and is then annealed inside this metal atmosphere. Then lastly, we have the analysis chamber. In the analysis chamber, we can do a UPS, XPS, ARPES and LEED. What this enables us to do is that we are able to get band information in the K-space, and we are also able to get a chemical species information and oxidation number, in addition to finding whether we have grown epitaxial films. What I'm using the Flextura system for is to deposit zinc oxynitride, which is I'm trying to make a tandem solar cell absorber, and that material has quite specific electric and optic requirements. So I'm using this high throughput depositions to really investigate a large parameter space, so that I am able to get the best possible candidate for a tandem solar cell.